450 tons, 17,500 miles per hour. 0 brakes. If this $100 billion space station falls out of control, it becomes a hypervelocity missile, carrying the kinetic energy of a tactical nuclear warhead. Left unchecked, orbital drag will pull the International Space Station an unguided death spiral, scattering hundreds of tons of molten titanium and steel across populated cities. This is the classified engineering strategy. NASA and SpaceX built to kill it first. To understand why we have to destroy history's most expensive machine, we have to look at the hidden physics tearing it apart from the inside. At 400 kilometers up, space isn't a total vacuum. It's a wispy soup of atomic oxygen. This constantly breaks the station's massive solar panels. Every 90 minutes, the ISS passes from extreme sunlight into total darkness, subjecting its metal joints to over 175,000 severe thermal expansion cycles. Decades of micrometeorite strikes, internal pressurization cycles, and structural fatigue mean the station cannot safely remain operational past 2030. When standard satellites reach the end of their lifespan, engineers kick them upward into a graveyard orbit, a cosmic junkyard 36,000 kilometers away, where dead spacecraft float safely forever. So why can't we do that for the ISS? Physics. Moving a 450 metric ton football field out of low Earth orbit requires an astronomical amount of delta V. Pushing the ISS to a graveyard orbit would require thousands of tons of propellant, more rocket fuel than the station could physically dock with or sustain structurally. Saving the station is impossible. Pushing it up is a pipe dream. The only choice left is to drag it down. To execute a controlled destruction, NASA awarded SpaceX an $8,443 million contract to design a specialized executioner, the Deorbit Vehicle. This isn't a standard Dragon capsule. Attached to the station's forward port, this modified trunk is packed with over 6 times the propellant capacity of a normal cruise ship. At its core is a brutal propulsion engine array, 46 SuperDraco thrusters, engineered to deliver massive thrust during atmospheric drag spikes. Unlike standard liquid oxygen engines that require complex ignition sequences, SuperDracos use hypergolic propellants that combust instantly on contact. In dense upper atmosphere drag, electric ion thrusters are far too weak. NASA needs thousands of pounds of instantaneous raw thrust to override atmospheric turbulence. The strategy is counterintuitive. For over a year, engineers will allow the ISS's orbit to decay naturally down to 220 kilometers. But once it hits the critical threshold, the USDV fires its engines in a massive, final retrograde burn. It acts as a giant orbital brake, locking the 450-ton station into a steep, non-negotiable death corridor toward the ocean. At 100 kilometers altitude, Mach 25 re-entry turns ambient air into a 3,000 degrees Celsius plasma shear wall. The station doesn't crash as one single object. It disintegrates in a precise, violent engineering sequence. At 80 kilometers, aerodynamic drag overpowers aluminum structural joints. The 73-meter solar array wings snap off like dry twigs and vaporize. By 50 kilometers, internal pressure seals fail. The thin aluminum walls of laboratories like Destiny and Columbus melt into glowing debris trails. Finally, at 40 kilometers, the main structural truss assembly fractures under aerodynamic shear.
Why do some parts survive while others vaporize? Low-density aluminum melts at just 660 degrees Celsius.
But dense titanium pressure nodes, steel docking rings, and thick fuel tanks withstand the heating, plummeting toward Earth at terminal velocity. An estimated 10 to 40% of the station's total mass will make it all the way through the atmosphere. To prevent a single human casualty, trajectory computers lock this 40-ton debris footprint into a precise location, Point Nemo. Located 2,600 kilometers from the nearest piece of land, the oceanic pole of inaccessibility is the ultimate spacecraft graveyard. The destruction of the ISS closes history's greatest chapter in global human spaceflight collaboration. But as it burns, it opens the door for commercial platforms like Axiom and Orbital Reef, paving the way for humanity's permanent industrial future in orbit. And join us next time as we dissect the 5,000-year mechanical illusion of money. Subscribe to Dissect to uncover the hidden physics, engineering, and mechanics shaping our world.